Welcome to lesson 2.2. This is on properties of logarithms. So we're going to learn 3 properties and then we're going to learn how to do some stuff with them. So we're going to evaluate expressions and then in the next lesson solve equations. Okay, so product property. This says that if you have 2 logarithms and you're adding them, so like log base b of x plus log base b of y, that's the same as a single log where the stuff inside is being multiplied. So basically, adding on the outside is the same as multiplication on the inside. And I think it probably helps to see an example. So say we had like log base 8 of 7 plus log base 8 of 4. That would be equal to log base 8 of, now we multiply the inside stuff, so 7 times 4 is 28. So adding on the outside, log of 7 plus log of 4 is the same as multiplying on the inside. It's the same as a single log where you do 7 times 4 on the inside to get 28. Okay, quotient property is similar, except instead of addition and multiplication, we're going to have subtraction and division. So if we have log base b of x and we subtract log base b of y, we're going to combine those into a single log with division, x over y. So subtraction on the outside of the logs is the same as division on the inside of the logs. So here's an example of that. Log base 12 of 100 minus log base 12 of 5 is equal to log base 12 of 100 divided by 5 is 20. So subtraction on the outside is the same as a division on the inside. Okay, finally, we have a property called the power property. And in this property, let's say we start with a log and we have an exponent inside the log. So log base b of x to the n power all inside the logarithm. The power property says that we can take this exponent inside the logarithm and bring it outside the log. This is actually the same as n times log base b of just x by itself. So an exponent inside is the same as multiplication outside. Okay, and an example of this would be like log base b of, let's see, I don't know, 3 squared is 9. So that's log, oh, I should give us a base. Log base 10. So that's log base 10 of 3 squared. Power property says I can take this exponent and bring it outside, and that this is going to be the same as 2 times log base 10 of just 3 by itself. Okay. So we might be wondering, like, why is this useful? And it actually allows us to evaluate some log expressions that we wouldn't be able to directly evaluate using our exponent chart. So let's see some examples of that. Okay, so for this first one, we're going to try to evaluate each of these expressions using log properties. So this one, we have a plus on the outside of the logs, and our power property tells us that addition outside is the same as multiplication inside. So we can use the product property to combine these. So this is going to be the same as a single logarithm, log base 6, where we multiply 48 and 27 on the inside. Okay, so 48 times 27, let's actually do that. And we get 1,296. And now we want to see, can we do log base 6 of 1,296? So let's see if we can do that. We're going to go to the exponent chart. We're asking ourselves in our brain, 6 to what power is 1,296? So here are the powers of 6. And here's the one we want, right? 1,296. That's the fourth power of 6. So this logarithm is equal to 4. To get from here to here, we said 6 to what power is 1296. So here we had two numbers that weren't powers of 6, 48 and 27, so we couldn't evaluate these using our exponent chart. We were able to put them together into a single logarithm that we could evaluate with our exponent chart. Okay, let's try another one. So for this one, we have a number multiplying outside the log, and our power property tells us that multiplying outside the log is the same as an exponent inside the log. So what we can do is we can bring this 9 inside and make it an exponent. So this equals log base 8 of 2 to the 9th power. Okay, we might not know 2 to the 9th power off the top of our heads, but we have an exponent chart that can help us. So let's look at our exponent chart. 2 to the 9th power is 512. So this is equal to log base 8 of 512. And now we want to know, okay, what is log base 8 of 512? So we're going to ask ourselves, 8 to what power is 512? That's our logarithm question. So let's go to our exponent chart and see if we can find 512 as a power of 8. Okay, so here are the powers of 8. Here's 512. That's the third power of 8. So that's telling me that this logarithm is equal to 3. And that's our final answer for that one. Okay, we're going to do one more. So this time we have subtraction outside our logarithm. And the quotient property here tells us that subtraction outside is the same as division inside. So I can put these together into one logarithm. Log base 5 of, I'm going to divide 208. 200 divided by 8. Okay, let's simplify that. So 200 divided by 8 is 25. So this is log base 5 of 25. And to evaluate that, we want to ask ourselves, okay, 5 to what power is 25? And you can totally use the exponent chart. You might also know off the top of your head that 5 squared is 25, 5 to the second power. So this logarithm will be equal to 2. Okay, we just have 2 more examples. In these examples, we're just going to combine each expression into a single logarithm. So first thing we want to do is take these numbers on the outside and bring them inside the logarithm as powers, right? So we know that I can bring these in, and this will become log base 6 of now x to the 4th power plus log base 6 of y to the 8th power. That's the power property of logarithms. Multiplication outside is the same as an exponent inside. Okay, and now we have addition outside, and we know that that's the same as multiplication inside. So I can combine these into a single logarithm by multiplying the inside stuff. X to the 4th times y to the 8th. And we're now in a single logarithm, so we're done. That's it. Okay, let's try that one more time. So again, first thing we can do is we can bring these numbers out front inside our logarithms as exponents. Multiplication outside is the same as an exponent inside. So we're going to get log base 5 of a to the 15th power minus log base 5 of a to the 3rd power. The 15 and the 3 become exponents. Okay, now we have a subtraction outside the logarithms, and we know that that's the same as division inside the logarithm. So log base 5 of, I can now divide a to the 15th and a to the 3rd. And we're in a single logarithm now, so we're basically done. The only thing is that we can actually simplify this a little more. So this is 15 a's being multiplied. We're dividing out 3 of those a's. So left over, we will have log base 5 of a to the 12th. You might know an exponent property that when you divide, you subtract the exponent. So 15 minus 3 is 12. All right, and now we're in a single logarithm. We're fully simplified, so we're done. Okay, that's a quick overview of how to use log properties to evaluate expressions and to combine things into a single logarithm.